Hello and welcome back once again to this video series of Hadoop Made Easy. We are discussing MapReduce problems. So this is the fifth video in this video series. So we are going to discuss about one more problem to have a good understanding or a decent understanding of thinking in terms of MapReduce. So the prerequisites for this videos are like video 1, 2, 3 and 4. So let's get started with yet another problem and see how we can actually approach it or how not to approach it in MapReduce. So the problem statement here is like you have an input file which is actually called sample.txt. The file name is sample.txt over here, and the file contents is like just two lines. This is a sample file fit for nothing. So the problem statement actually is that we are supposed to find out the average length of all the words in this text file. So if you do it manually, if you just try to give a dry run of the logic, so the word this is having a length of 4, the word is having a length of 2, the letter A is having a length of 1, and so on. When you try to add up everything together, you're going to get a length of 30. The length of all the words is going to be 30, and total number of words in the above file is going to be 8. So when you compute the average, you're going to get the output as 3.75. So the final output of running this program in a Hadoop cluster, we're supposed to get the output as 3.75, and which is nothing but the average length of all the words in this file. So let's try to see how we can actually think in terms of MapReduce to solve this problem. So I don't have to explain everything about record readers. You pretty much have to understand that the record reader is going to give you a key and a value pair, where the key is going to be the file offset and the value is going to be the entire line of the file. It's going to read one line at a time. So when the record reader actually processes the first line of the file, it's going to give 0 followed by the first line. Now above key value pair is now going to be fed into the mapper as an input. So let's see how we are actually going to program the mapper. So in this problem, I decide to program the mapper according to the way I think it's going to be right. So this is just one way of programming the mapper. So what I do is like I ignore the key from the record reader, and I split in a step 2. I pretty much split all the words in the list of values, which is going to be the entire line. So I'm going to split it. This is going to be the input line to the mapper. This is a sample file. So I'm going to split each individual words and then just store it in a temporary variable or in a buffer or in a string buffer, whatever it is. Now in step 3, what I do is like I output the number as key. The reason why I'm outputting the number as key and value is like mapper accepts the input as key and values, and the mapper is supposed to output key and values. So for everything what I process in the mapper, I'm supposed to give out the output in terms of key and value pairs. It has to be in a tuple of 2. It has to be a double valued output. So I decide to actually give a key of 1 because I'm the programmer. I can decide what I'm going to give the value of key as and what exactly has to be the value is. So I decide that my key has to be an integer 1 or a number which is 1, and value has to be every single word. So when I repeat this operation after processing the complete line, the output of the mapper is going to look pretty much like this. So after I process the entire file, my output is going to look like this. So if you go back, you see the two lines of the input file. This is a sample file fit for nothing, and after the mapper processes the entire two lines, this is going to be the output. So for every word there's going to be a key which is 1, which I decide as a programmer, and the value is going to be the word. So now this particular intermediate file, which is generated as a result of running the mapper on the input split or on the input file, so what would happen is the subsequent operation which is going to be happening on this intermediate file is going to be sort and shuffle. But as I told you, when you do the sorting operation, sorting happens based on the keys. So since all the keys have the same number, so eventually sorting doesn't produce any different result. Of course, sorting will happen, but the file will remain unchanged as before sorting, and after sorting the file is not changed at all because sorting happens based on keys. Now, what would happen after shuffling? Yes, shuffling is a phase where duplicate keys are removed. Since all the keys are repeated, so aggregation of the values associated with all the keys would happen. So what would happen after the shuffle phase is like you have one key and the value is now going to be a list of items which is the entire content of the file. This is a sample file fit for nothing. was the original content of the file, which was having two lines. Now all those two lines is now coming into a single line. Observe carefully, we are having one key and a list of values which is going to contain nothing but all the words from the input split what the mapper is processing. In this case, the input split is the entire file. So we would have all the words in the file appearing as a list of values. So observe carefully, if I have this as an input to the reducer, if I have this key value pair in a file, which is a result of sort and shuffle operation to the reducer, how would I actually compute the average? It's possible. How do I compute the average? It's pretty much possible. Can we just traverse or pass the entire list of values one by one? Yes, I can. Now, when I'm traversing the entire list of values, can I add up the length of each word and store it in a variable? Yes, basically when I finish traversing the entire list of values, I can have the length of all the words. At the same time, when I'm actually traversing or when I'm parsing the entire list of values, I can also pretty much, like calculate or figure out how many words are there in the entire list. So eventually, I've successfully found out how many words are there in the entire list of values and how many characters are there in the entire line. So I have the length of all the words, the sum of length of all the words, and total number of words. I can divide one by the other and still get the average. So logically, this looks fine. But wait, what if the input file is actually of size, say, 500 GB? Now, according to the programming logic, what we have adopted here for MapReduce, our entire line or the entire file actually, the entire file of 500 GB is now going to be as a single line in the key value pair of the output file of the reducer. I mean, as the input file to the reducer, not the output file. So when the reducer actually is trying to operate on an input file, the input file will be having just one key and a value, which is the entire 500 GB file. So the reducer will now have to process the data of entire 500 GB in a single file residing on a single machine. This is not what MapReduce actually was originally designed for. The whole purpose of having MapReduce is for having parallel processing. Of course, yes, we did everything logically correct here. So we had the mapper work on something, we had the reducer working on something. So the flow of data or the flow of steps from mapper to reducer looks almost correct, but there is a big flaw in the logic what we have adopted over here. There's a big mistake what we have done. The result of this MapReduce is like we are getting the entire file into one single node. So what did the mapper do? Did the mapper do something useful? Definitely no. So what is the reducer going to do? It's going to process the entire 500 GB of file in one single data node. The whole purpose of having distributed processing, the Hadoop, the MapReduce fails over here. So this is an example which I deliberately included to show you how not to use MapReduce. So if you make such kind of mistakes, it's going to actually be a big performance overhead. It's never actually going to give you the result in a very short time. It's going to take a very long time, and we are unnecessarily wasted time in doing the mapper steps, which eventually did nothing useful in reducing the computation time. In fact, it's an overhead operations what happens in mapper, and finally we have the entire 500 GB of file sitting to be processed to find out the average length of the words in one single data node as a result of reducer operation. So this is a classic example of how not to think in terms of MapReduce. So I would actually leave it as an open question to the audience, where you can think a more logical and a more appropriate way of writing MapReduce code to solve the same problem of finding out the average length of words in a file. So I hope you actually got a pinch of doing a fundamental mistake in thinking in terms of MapReduce in the wrong way by going through this example. So that's it for now. Hope you enjoyed it. Goodbye.